Good morning, everyone. Thank you very much for joining today on Saturday morning in India. So, Cybersecure India is arranging this expert talk series, and this is one of the part of our expert talk series. And today, again, we have a very unique topic and very unique speaker also here, Mr. Yugal Patak. So thank you very much, Yugalji, for joining with us and spending your time and expertise basically for the community. Cybersecurity India is a non-profit initiative by Feather CSI Foundation and has been working into the cyberspace since 2014. And we have been conducted, like trained more than 50,000 people all around, may it be law enforcement, may it be schools, colleges, nationally and internationally, both may it be corporates and all. Also, we are doing a lot of like contribution towards decreasing the number of cyber crimes in many aspects. One is by creating such awareness programs, and other is basically by creating awareness by helping to solve the cases basically which are happening beside towards the cyberspace. So that is what Cybersecurity India is doing. And currently we are also launching a new batch on the 1st of April. The forms of the same will be rolled out on 18th of March. That is what I can say. And other information you can get on our LinkedIn channel. So thank you very much again, everyone, for joining. And welcome, Yugal sir, for this talk. So I'll just give you a short introduction of Yugal sir. So Yugal is currently working as a digital forensic analyst with ESEC Quality Technologies. It is one of the leading digital forensics company, and engaged with forensic community also as a researcher and avid learning. Yugal's area of interests and passion are like includes digital forensic incident response research, learning and sharing knowledge on the field of cybersecurity, digital forensics, incident response, and cyber intelligence also. Also, he has a good knowledge of cybercrime investigation and solving cases related to digital forensics for law enforcement departments, as well as he is working in incident investigation for corporate clients. Right. So, thank you very much, Yugalji, for joining, and you may also introduce if I have missed out any part of the introduction. So, thank you very much once again for taking out your valuable time and joining here. Thank you. Over to you.
Yeah, thank you, Nikhil, for introducing me, and it was very nice introduction. I'm very happy for that. Yeah, so firstly, good morning to all of the participants here who have joined live. And I guess this is my first session here on Cybersecurity India, and I'm very, very privileged that I was given this opportunity. And as he said that, yes, this expert talk series is basically exploring different, domains of digital forensics and, different topics. So today we'll be talking about open source tools and what are the validity of open source tools, how we'll be working with open source tools, and the most important thing is the open source tools investigation right or valid in the court of law or not, because whatever we do in digital forensics, the most important thing is it should be valid in the court of law. So there comes our point. Now, just let me share my screen. I hope my screen is visible to you.
Yes, it is visible. Thank you. Thank you. And everyone, the audience can ask their questions over the chat.
So let's begin. Now, firstly, we say digital forensics. Okay. In digital forensics, here I have written a word, and the word goes like this. Security is a myth. It was a quote sometime, but now it's no more. Why we say this? Because now it has become a nightmare in digital forensics. Like as the security is increasing, the digital forensics challenges are increasing day by day. And in the same way is the amount of data, volume of data, and the amount of digital evidences. So everything is increasing exponentially together, which is causing a very big challenge for digital forensic investigators. Basically, we'll discuss firstly what is digital forensics. So here's a short introduction about me. I'm basically a digital forensic analyst with ESEC 40 Technologies. And if anyone wants to connect with me, they can connect with me on cyberub4u@gmail.com or my LinkedIn. And before that, I have been working in the roles of in the SOC department in as a digital forensic examination tools. And I have also worked with the law enforcement in Uttarakhand Police and some other police departments. And with that, my scope is mainly in the area of R&D in case of especially social media forensics and memory forensics and dark web. I am highly interested into it. So if anyone wants to connect with me, they can connect it. Now, let's go with the beginning. What is the source of information? Source of information basically means whatever the data we say we are going to acquire in digital forensics, it's all the data which is acquired from different sources. For example, different softwares, different commercial services, different online sources, offline sources, like we have the laptops, hard drive, digital devices, the online sources, we have the clouds, we have the social media accounts. Commercial services, we have people are using some accounts like Amazon accounts are there, their Facebook accounts are there, the different kind of services they are using, and different kind of softwares they are using in their devices. So source of information is a very big open area, anywhere the information can occur, and there are multiple sources for that. Now, what is the digital footprint? We actually, in every source of information, we are finding only one thing in case of digital forensics, that is a digital footprint. Now, what is a digital footprint? Every day we are, contributing a lot of data into this world. For example, we are buying something, we are selling something, we are talking to someone, we are messaging someone, chatting someone, creating files in the system, working for the organization, working for our personal benefits, like other than organization. Everywhere we are creating some data. For example, our personally identifiable data, our personally identifiable health information, our personally identifiable financial information. Okay, we have taken so many loans, we have taken so many EMIs, we are paying that. So everywhere we are generating some data, we are transmitting it, processing it through different systems, and it is getting collected somewhere, either in form of some offline mode or in the online mode. So whenever we are actually sending some information or receiving some information, we think that it is limited to us. That's wrong. Actually, we are in a huge auditorium where we are speaking into a public address system, and a world is there which is recording and distributing whatever we are giving to them. So everywhere we go, it's our digital footprint. Now, here I have shown you a small picture. In digital forensics, what are the digital footprints we can find? Like, for example, someone created an account on YouTube, someone created an account on Facebook. That isn't temporary, it is permanent. He created the account, he left his digital footprint. Data, it can be extracted by the law enforcement by accessing Facebook's servers, right? Someone created a file into the system. That file can be actually extracted from many places into the system because the footprint is permanent. Okay, someone access some system or message someone, the other person took the screenshot, the other person took the chat backup, the footprint is permanent. So whatever happens in digital forensics or in the digital world, it is actually a permanent footprint. And in digital forensics, it is a process of scientifically analyzing the devices. Now, what are the devices? Network devices, digital devices like storage devices. Okay, the network file systems. Okay, the servers, the cloud systems, the IoT systems. And nowadays, if we talk about modern times, the smart devices and different kind of devices, which we are trying to acquire the data from. And what we are doing in it, we are firstly identifying what is the evidence, then we are assessing, is it a digital evidence or not? Now, here I like to put a small term. Some people say every electronic device is an evidence. I would say no, not every electronic device is an evidence, because if you have a TV in your home, a smart TV would be a digital evidence, but a normal TV won't be a digital evidence. Okay. If we say every digital evidence, we have speakers also. We have, washing machines also. We have microwave ovens also. Many electronic devices in the home. Every electronic device is not an evidence. Whatever is storing some data, processing some data, transmitting some data, like wherever there will be a dissemination of data, that will be a valid digital evidence. Now we are identifying it, assessing it, then we are seizing it. Now seizure has to be done like either we are seizing the device or we are making its image or we are imaging the device. If the seizure cannot be performed, we are making the images. Now there are also two types of images. One is the cloning kind of thing, and one is the logical imaging or the just the data we are needing, we are extracting that much amount of data. That I'll cover further. Okay. Next is preservation, preserving that thing. Imaging, I told you already. Analysis of digital evidence. Now analysis means after imaging or after seizing the device, we'll now dig out the data of the device to find whatever is the relevant evidence we need or the root cause of the incident or crime. That is what is the process. Now, if we see a flowchart small, identification, assessment, seizure or acquisition. Okay, acquisition and seizure, they are basically mostly same. Just a slight difference is there. Imaging, integrity verification, analysis, documentation, and report preparation for submission to law enforcement. That is the most important part. Just finding the digital evidence won't be enough. Actually correlating the digital evidence to the case we have or to the crime that was occurred is the most important thing, because until and unless the evidence cannot be proved into the court to be related with the case or the crime, or the evidence cannot be proved as authentic, it is of no use. Now, evidence comes, we either acquire it, the image, okay, then indexing is done. Now what indexing is? Basically indexing means we are creating a directory. Like we have a phone directory in our home. What phone directory does? Although we know all the mobile numbers, right? But we are creating a directory so that we are able to easily access them. We find C letter, all the numbers which are related to C number, we are easily able to get it. We see D alphabet. In phone also we have the same format. We are able to get all the people phone numbers whose name starting with D. So similarly is the indexing in the digital forensics world. Whenever you are having a digital device or a hard disk or a pen drive or some kind of digital evidence, there's a lot of data. There are spreadsheets, there are JPG files, there are PPTs, there are data files, operating system files. There are some Word documents. There are Excel sheets containing some emails, phone numbers. Some WhatsApp chats are there. Everything is there. Now, what indexing does? It pulls out the essential keywords or the essential data from those all digital evidence items and makes a list so that you are easily be able to access it. Now, what happens? You will come to know how many images are there, how many videos are there, how many documents are there, how many PPTs are there, everything. Now analysis. Now analysis of two types. One is analysis by the tool, like tool will give you some information, and then it is manual analysis. Investigator will be manually analyzing it, whether it is correlating or not. Then what happens? We are creating a report. After report, the report is given to the attorney or the judge. Okay, and in the last, the evidence has to be archived for a long time, so that till the case does not get over, the evidence should be there. Like for example, some case closed in the lower court, but the person who got the punishment, he applied into the higher court, high court, supreme court. Okay, so what happens when the case will go there? Again, the reanalysis may be performed, or if the same analysis has been carried out and it has been taken forward, the evidence may be asked to reconfirm whether there is any change or not, or complete new investigation can be carried out. So the evidence has to be archived for long time. Now, there are two roles in digital forensic investigation. One is forensic responder, one is forensic analyst. Now, what are the potential digital evidences? I'll go very short on it. In the old trend, we had computer system, hard disk, removable media, USB drives, pen drives, everything was there, which was known to us. Now in new trend, with this, we also have device logs, we have video footages and images, we have archives, we have active data, metadata. Okay, we have IoT device data, emails, you have UAV systems, drones, which are, you have DVRs of CCTVs. Okay, you have social media accounts, you have cloud workspaces like Azure, Google, and then we have AWS, and you have gaming consoles. Different gaming consoles are also there nowadays. So now integrity of digital evidence. Integrity of digital evidence, if we talk about it, it basically means we have to keep the hash of the digital evidence so that its validity is maintained. And the hashing is most important part in any digital forensic evidence tool, okay, evidence analysis tool, so that the integrity of the evidence can be challenged into the code or it can be proved into the code if it is asked upon. And what are the hashing we use? Basically MD5, SHA-1, SHA-12, and SHA-256. Different hashing algorithms are there for that. Now, if you're going for an open source thing, now firstly, let me make you clear what is open source. See, open source basically means a tool whose source code is available, openly for everyone. Anyone can make changes into it. Anyone can update the tool, okay, and anyone can publish it with due respect and due credit to the creator of the tool, okay, and it will not be considered a theft. So there are many open source tools available in the world of digital forensics, but most less digital forensic tools are available in the field of mobile forensics, cloud forensics. Like there are some fields in digital forensic also where very less digital forensic open source tools are available. We have some tools like Autopsy is there, FTK Imager is there. We have RAM capturer is there, and we have different tools we have available in the field of disk forensics. But in case of mobile forensics, in case of cloud forensics, in case of IoT forensics, we have very less tools available, and that is a challenge because there we have to go for the commercial and paid tools, and commercial and paid tools are not actually profitable for small investigations. Yeah, if you are a big and good law enforcement agency and you have to do everyday investigation, then definitely you should go for the professional tools, okay, because it is easy for you to do investigation with them and they provide you additional functionality. But yeah, if you're a small organization, if you are just starting up, you are a new student who is starting into digital forensics, open source is the best way to explore digital forensics. Now, if you are creating a digital forensic lab with open source tools, what are the steps you should keep in mind? Determine the scope of investigation and available platform for establishing the lab. Now, the scope of investigation means basically what things you need to investigate into that lab. Okay. Now you want to investigate what kind of mobile phones. Like if you are trying to, analyze Apple phones or Mac devices in the open source lab, and you are relying completely on open source tools, that I think won't go much better. Then in case of if you are trying to analyze a hard disk, if you're trying to analyze a SSD, if you're trying to analyze some kind of USB drive, because that is easy. If you are trying to extract some data from WhatsApp or some kind of social media application from a mobile phone, in that case open source tools may help a little but not much, okay. You also need to determine the cost factor, including in procuring the hardware for the lab. Now, you can get open source tools like softwares for the lab, but open source hardware is not available most of the time. So for hardware, you will definitely have to put some cost there. And for running open source tools, also you need a good hardware so that the tools do not choke their efficiency. Now, determining the users in the lab and capacity of evidence to be analyzed, that determines the type of workstation. Now, see, workstation is the most important thing in the digital forensic laboratory because whenever you are working with any kind of tool, the most important requirement is the processing power. For processing power, you should have a good RAM, a good ROM. There are large digital evidences like 1 TB, 3 TB, 5 TB. So your workstation should have a good amount of memory also in case you want to analyze it, because if the image is being made into the system or if it is made outside the system also, in that case you need a lot of storage space also. Now the third thing is you should have a separate cache drive, separate data drive, separate OS drive, so that the efficiency of the system is not compromised. Then next is the integrity. Your system should have a very good security features. Okay, you should have a very good redundant system. It does not fails again and again. It does not crash at any moment of time, so that your all the investigation is lost. So a type of good workstation is very much recommended, and I'll go more on it further. Now, collect the softwares and the tools required to be installed in the systems and determine their capability with scope of the investigation. Now, the softwares and tools what you are required, you have to collect it from different sources. Some are available in form of Linux tools, some are available in form of distros like Kale is there, Deft is there, Expresso is there, and Nopix is there, Nopix STD. There are different types of tool available. Okay, a different type of operating system also available. Like Paradigm is also there, which is available. So you have to determine what you require and what is your scope of investigation. Then the next thing it will be where you are going to install the tool and what is the usage of the tool, like how many digital evidences you are going to process into the tool. Okay, it does not matter that what is the tool efficiency, but what matters is what will be the usage of the tool. Like if you're trying to image 10 drives together into a free open source tool, it won't go good that much. But yeah, if you are trying to go for single one or two images or single one or two evidences, that would go better. Now install the tools and test the case for the expected output. If required, upgrade the change the tools according to requirement. Now there is a problem with open source tools. The problem is that the source code updates are not very frequent, as it is very frequent in case of paid tools, because they are commercial tools and the customers are already for them. So they are regularly in the updates. In case of open source tools, the updates do not come regularly. Like some tools they have got updated in 2014. After that, no update came, and it is working in the same way. Okay, and the step 5 is maintain a record of tool versions and updates and make sure all tools are reliable and compliant to local law guidelines. This is the most important point I would say. Some tool is there, some person made it into the GitHub, you pick up the tool and you start analyzing from it. Later, when you go to the code, you get to know that that tool, was not the one which the law enforcement are expecting, or they are not able to accept into the code because it is made by some individual person in the GitHub. Okay, although it gave you all the information, and you may say that your investigation was complete, but later a reinvestigation may be asked to give the same report from a commercial tool, and if it matches, then your investigation may be put up into the code. Because the biggest thing comes with the open source tools is their compatibility and their integrity. Will it be able to be challenged in the court? Will it be validated by the judge? Will it be validated by the lawyers there and the police officials? That is the very biggest challenge. Now, I have a list of open source tools, a small list. Okay. In case of operating systems, we can say Kali Linux, we have the Parrot is there, Kale, Def, CSI Linux is there, Nopix is there, Deft is there. Okay, these all operating systems are having a lot of tools inside them for you to analyze. Next is, in case of computer forensics, Autopsy is there, the most famous tool. SANS investigative tool is SIFT we have. Okay, Oxygen forensic suite and SDK imager, right? Okay, one more thing to make clear, all the open source tools are not free, and all free tools are not open source. This is a a double-edged sword. Next, memory forensics, we have Volatility Workbench, we have Registry Recon, we have Memorize, Auto Timeliner. In mobile forensics, we have MVT, which is a tool which is offering some of the functionality but very less. Then in case of Swift, we have, okay, then network forensic tools, we have Wireshark, Network Miner, Expresso, Nessus, and Map. Network forensics, we have a lot of open source tools. Okay, in IoT forensics, Edify OS is there, Kali Linux is there. In case of audio video forensics, we have Video Cleaner, we have, and we have photo forensics also there for identification, and many of the OSINT tools are there. In case of audio video forensics, we have got a list of OSINT tools, open source intelligence tools, which are also helping us do the same purpose as the forensics. Next is DCAF or Abby Hunter for software forensics. Now, for social media browser forensics, we have Web Preserver, we have Make a Website Hub, People Search, Deny, TweetBeaver, we have the Web Archive, that is the Wayback Machine. Okay, desktop app and Chrome plugins are there many. Okay, then we have many Python tools which can be downloaded from the GitHub and installed in the system and used. In case of anti-forensic, if we say we have a very good tool, Eraser, which is an open source tool, which will do erasing work very frequently. I have not mentioned more of the tools because there are many tools, but I have personally used Eraser and I prefer that. It's a good tool. And some other tools are forensic hash database to keep your database of forensic hashes if you are dealing with many evidences. We have hex editor, Neo, okay, we have USB historian. So many of the tools are there. The list goes very long, and there are some websites also where you can find these lists like DFI device there, DFI.training is there. Okay, then we have DFI blog. So we have different side of sites where you can find the same tools. Now, what are the challenges with open source tools? The challenges with open source tools comes when we are having, the comparison between commercial and open source tools. What happens? See, open source tools, its source code is openly available. Commercial tool, the source code will not be available openly. It will be proprietary of the company. Open source tool is developed and maintained by community. Commercial tools are maintained by a group of company or a organization which is owning it. Now, the community in case of open source tools may exist. Sometimes the community gets resolved, so the tool update will never come. Sometimes the tool which was created, the GitHub was there, but the repository is archived now. The repository is no more available. Some digital forensic tools are there who were available once, but now they have been extended because of the latest updates in the technology, and the tools were not being able to get update with the same pace because the developers do not pay heed, they do not pay attention. Okay, the development and testing of open source tools are not governed by a single body, and thus reliability of tools may be questioned. The tools may be tested, not tested, or maybe tested on a very limited data set, okay, or maybe tested for a specific use case only. So the reliability of the tools may be questioned every time. In case of commercial tools, it has a proper testing environment and secure testing environment made by the OEM for the testing of tools. And all the tools which are being tested have to clear the same secure testing environment, and then only they'll be launched in the market. And later, if you question the validity of the tool, they can be validated by the OEM of the tool. Now, in open source tools, users do not need to have a license to use the software. That's why it's called open source. It's free. Okay. Users need to buy a subscription in case of commercial tools. Now, in case of open source tools, we have a limited intellectual property rights because it's not someone's property. It's the property of the creator or the open source community. In case of commercial tools, we have full intellectual property rights. In case of open source tools, there are very less or limited support available through community. Like for example, I told you as the developer of the tool is there, you message him, you mail him, you text him for any update in the tool, for any bug in the tool. It may be patched, it may not be patched. If you are, some good person, you can yourself make a new version of the tool and patch it. But most of the time, if you message the developer, he may answer, he may not answer. Maybe he has left the tool. Maybe he's now not working digital forensics. So that support cannot be guaranteed. You will get the support for the open source tools. Okay. In case of commercial tools, the OEM has a dedicated support system, and you can get it dedicatedly. Now, next, in the last case of open source tools, usually developed and maintained by research and non-profit communities, and usually they are, basically made for different new kind of use cases and new kind of cases. For example, I'll say if you go in case of the research R&D, the open source tools will be more better because it may be exactly be able to be molded, and you can attach your own plugins into it. You can attach your own codes into it. You can mold it yourself so that for a specific purpose. Okay, in case of the corporate tools or the commercial tools, this thing can be limited because the OEM may allow you to embed it with other tools or not. The OEM may allow you to integrate it with other codes or everything or not. That may be limited. So there are pros and cons of both the tools which I explained here. But I will mostly prefer, if you are a beginner, if you are a new person, you should not go for commercial tools, you should go for open source tools. But there are different challenges with them also, which you should keep in mind while using the open source tools. Now, after this, now I like to go for a demo of just the open source tools, that is Autopsy. So just mind sharing me 2 minutes. And then the end will go about the what are the hindrances to digital forensics and investigations. Open source tools, what are the some challenges which we face from it, and we need to work on them. And then we'll have question answer session. So I hope my screen is visible to all of you. Autopsy is a very famous open source tool, and it is basically helping us in the most of the investigations. In case of data forensics, and I will say like FTK, Imager, and Autopsy, they are very good tools which can basically aid our investigations in case of we are going for very small evidence. Just I'll give you a overview of what is autopsy and how it can be used for some open source investigations. I hope my screen is visible.
Yes, sir.
Yeah. So this is what is the autopsy tool, or it is also available in the command line format called Sleuth Autopsy Toolkit. And basically it is being developed and maintained by Basis Technology, which is organization working to create this. And they have one more tool, which is Cyber Triage. Cyber Triage is although not an tool, it's a paid tool, but yeah, you can get free demo of it, but it's also a very good tool. But this tool Autopsy, it is completely free. So anyone starting to digital forensics may go with FTK Imager and Autopsy in that case. Now, if we see the overview of the Autopsy, here we have different capabilities here, like we can create a new case, we can unpack an old case, okay, we can close the case, delete the cases, we can manage the host, we can going to the view section, we can use the Autopsy as a full screen also, okay, and then we can remove the full screen option also. In case of tool, we have here the tools for image and video analysis, for communication analysis, geolocation, timeline, discovery of evidences. Okay, we can do file search by attributes. We have different ingest modules also for autopsy. We can use external plugins here. See, this I said, most of the open source tools, they give you an freedom to use many plugins like Python plugins and different kind of plugins available in the GitHub, also available in the open source community, which you can integrate with them and you can do the easy analysis. Now we have different options also here for this. Okay, making live triage drive, we can create a live triage drive also using a pen drive with Autopsy, and you can create a logical imager also. So now let's create a new case into this. So if I go here, the case name, I'll put it a test case. Okay, now here comes the directory where I need to save the case. So I will go into my data section, and here I have a folder called demo analysis. Here I will save it. And although I have here already the test case, so I need to create a new folder. In this folder, I'm going to save it. Okay, now see the case, it can be a single user also, multi-user also. Okay, so Yeah, it's the open source tool and it is giving you the functionality of using it as a single user and a multi-user, both the things. Now going to next. Here all the basic details of the case, what we can add, like case number, I put it 100. I put the examiner name, anything. Then the phone number, let's give it blank. The email can be, and notes, you can put any notes related to the case. Now, the organization for whom it has to be done, it can be specified here. Here I can manage the organization name also. Like for example, here is my organization. Okay, in the POC, I can put my name as I'll the POC for that. Okay. Now I have added the organization here. So now I can select the organization. So if, for example, you are working into a department where you have integrating 2 or 3, different uh, cases. For example, there is a police department where it is handling cyber cases also, it is handling narcotics cases also, it is handling economic offense cases also. So here, the managing the different categories of the cases through organizations and managing different organizations. Like if a tool is used by, some police STF also, it is being used by ATS also, it is being used by, normal SOG also. So different organization setup can help you easily identify the cases. Now I finish it up here. Now see, it is giving me a opportunity to generate a new host name based on data source name, specify the new host name or use existing host. Okay, so I'll go for generate new host name based on data source name. Now, what data sources it is allowing me to ingest? It is allowing me to ingest disk image or a virtual machine file, a local disk file. Okay, the local disk which I have in my system, the physical drive, logical files, unallocated space image file, okay, which we make it. Autopsy logical imager results. Autopsy logical imager is also there. We can use that for imaging and later we can ingest the file into it. And XRY text report. XRY is a tool which is used for digital forensic analysis. So if you can also import the XRY text report into it. Okay. And that you can use as a data source into Autopsy. Now I'll go for a disk image or VM file. Now it will ask me to browse the file. Let me check where I have the file with me. Okay, there I have a E01 file here. Okay, it's a random file which I have bought from internet. Okay, for the analysis. Now here I can set up the time zone. Okay, what is the time zone of my investigation? If it is some kind of other time zone, like for example, if I am working in some other time zone like Nigeria, if I'm working in some other time zone like US, like Australia, Sri Lanka, I can select that here. And now comes the sector size. Now sector size, you can select the sector size, what it should detect into your drive. If you know earlier what the sector, default sector size is, then you can set it here. But since we don't know about this image, we'll go for auto detect feature. Okay. Now go for next. Now see what different ingest modules it is allowing me to work here with. Okay, recent activity, hash lookup, file type identification. I can define what type of file it is. Extension mismatch detector. Like sometime what happens, criminals manually change the extension of the files so that they are undetectable. They does not open. So it will detect that. Embedded file extractor. Okay, some file is embedded into some other file, it can be able to extract it. Picture analyzer, some images there, it will be able to analyze the image if some kind of hiding or something has been done into the image. Keyword search, okay, searching for a specific keyword. Email parser, parsing the emails which are available into the data source. Then next is encryption detection, detection of some kind of encryption into the drive or encrypted files. Interesting files identifier. Now interesting file identifier means if there is some file which is not as a normal file which is having some specific properties which we can set up in the rules for interesting files, so it will be finding that. Okay, photorack carver. Photorack is again a open source tool, as you must be knowing, so it is using the photorack also here. Okay, virtual machine extractor. If some virtual machine we are putting some vmdk files, in that case it will be able to extract the virtual machine, complete virtual machine from it. Data source integrity, by validating and calculating the hashes of the data source. And Android analyzer. Okay, Android analyzer is again the open source module. So if there is some kind of Android data present into it, into the image we are sharing, it will be able to analyze it and pick up the data. Drone analyzer, like if it is some kind of DJI drone, or there is some kind of data available directly to a drone, that will be able to analyze it. Now see, Plaso. What is Plaso? Plaso is actually again a open source tool. Okay, it's a module which will be able to parse for the registry files and for the registry executable, portable executable files. Okay, so taking the Plaso would need me to do a live imaging of the system, so I'll not put it. Yara analyzer. Now Yara rules are very famous, everyone must be knowing about it. Yara rules are basically from which we are analyzing that a tool is a image or file is a malware or not. So this tool is basically using Yara analyzer also, as in an open source way. Now iOS analyzer, if there are some iOS related data, it will be able to analyze it. Okay, and at the last, Android analyzer. So I am selecting whatever is the default configuration, then I'm going to next. Now the data source is being added into it. Okay, now if we go for FTK imager and autopsy, okay, let it finish. Yeah, it's finished now. Now if we go here, what files we are able to see into it. See, this is the basically tree structure where we are going to see here. See, in the data sources, we'll be able to see different kind of data sources. So here we have Jimmy Wilson, some kind of file. Okay, this is a file where there were different volumes when it was connected to a system. So there were these many volumes. Volume 1 unallocated. Volume 4 is Microsoft reserved partition, like which is reserved for the Windows, the default partition. This is again unallocated partition. This was the basic data partition or the main drive. Okay, and volume 7 is again unallocated. Now, if we go to the file views, here we are able to view different type of files. From file types, we'll be able to see what type of files are there. Now, if we go by the extension, so these many file extensions are available here. It is showing us the number. Like 26 database files are there, 11 archives are there, 1 audio file is there, 11 video files are there here, and these many images are there. 1917 images, 1917 images are available there. Okay, now when I go for the deleted file, there is a separate section for deleted files. So 2197 files were deleted from this device, and see, these are all the deleted files. That's a very long list if I keep on going. And now if we see here, let me extend it out. See, what we are showing, it is showing us here. See, first of all, the most important thing in a digital evidence is the MAC details, modified, access created. So it is showing us the time when the file was last modified, when it was changed, when it was accessed. Okay, and if we see here, we are able to see the file metadata into the hex form here. Then the size of the the file, where it was, which directory, okay, where the metadata of the file is available. The file is known or unknown, because it's deleted, it will show unknown. And what was the location of the file, where it was stored. This is the location of the file. So if we see here, we are able to see all the details. For example, if I click on this, see, this is the detail of the file metadata. The name of the file is this. It's a JS file. The type is a file system. MIME, it's an octet stream file. Okay. Size is 0. File allocation is unallocated. The MAC details, it's showing 0 because the file was deleted. And the MD5, the hash is not calculated because it cannot be calculated for the deleted files. And this is, and if you go for the available files, for example, I select some file, yeah, this, for example, this image is there. If I go for the file metadata, see, it is showing me the file metadata file. This is available as image file, and the name of the image is image scbq09vj.jpg. The modified time was this, access time was, and the created time was this. And if I go below for the more data, see, from the Solid toolkit, it is able to extract these much data about the file. What is the owner ID of the file, the security ID of the file, the created, modified, okay, the access time. It is showing it in IST, and the file name attribute values. See, here's a very important thing you can get here. The MAC data of the file is always used to identify whether the file is, present into the system or not, because here you'll be able to see the which system the file is, what was the MAC time of the file, again, what was the parent directory of the file. Okay, file name attributes is there, the file attributes are there. So these all are present into the metadata. Now coming down, we go for data artifacts. Let me go by minimizing each of them. Yeah, in case of data artifacts, we are here. So in case of communication accounts, see, we have emails here, 38 emails. And if I open one of them, this is one of the email I can open here. It's a .eml file. See, it's showing me the Gmail folder of the person. Okay, and here, let me if you show this. See this here. Yeah. So see here. Here I open it. Whatever data is available with me there. For example, I click on this email and I open the email here. See, the different names of the users present into the system, the app data folder, the credential, device metadata, feeds, Internet Explorer, media player, the Gmail folder. If I click on this is the Gmail folder, the outbox, the Sentinel is the folder there, storage folder is there, proof is a folder there, then Windows Mail, Windows Media, then the temporary internet files, okay, which we are usually clearing from the temp command, the contacts available there, application data, cookies, desktop, what was available in the desktop. Okay, in desktop there is some kind of a folder, and if I click on here, Billy D goat, yeah, see, a goat picture is there. John T Wolf, there is a wolf is there. Somebody's photo is being morphed with a wolf here, and there is some kind of text file. If I read the text of the file, it is some kind of encoded message. Then I go for music here. So there are different kind of files here. Now let me minimize it. If I go for email messages and install programs, yeah, especially install programs, all the software names which are installed in the system come to me here. Okay, including the system files also. What are the system files available in the system? He has used TrueCrypt. He has used KeyPass for keeping the password. He used Skype into the system. Okay, and date and time was 4 to 2014, and this was a time. And next, I go for wait, any other software? Yeah, he has used Director EX font code. Okay, so these are the applications he's using. Now going for metadata. These are the metadata files available here of different applications. Operating system information. Okay, if I go for the system information, see, let me get you off. This is the system information. Okay, available here in form of this. See, this is, read it. Date and time. The device model is root hub. Device ID is this, whatever device was used. The artifact ID is a unique ID here, available here. Okay. If I go for the system logs, these are the system logs available. And some of the files are deleted actually, because time to time they are deleted automatically. In the recycle bin, we have the 14 files here. Some PDF files also available there, and the image files are there, different kind of. See, there are small different files available here. Okay, now if I go here into the different features of Autopsy. So if I go here, let me select the data source. It is showing me all the images. Okay, for the Jimmy Wilson. So see here, I'll be able to see a gallery viewer. There is separate image gallery viewer present into Autopsy, where you can see all the image files. Now I guess the ingest is going on. Yeah, the ingest is going on. It's 85%. So it is slowing down a little. We will go on it later. Yeah. Now, these are the shell bags available here. Now, talking about shell bags are very important in case of digital forensics, because shell bags are giving us information, whatever data was being, what are the different file attributes, the file locations which were available there. So, shell bags have a very important existence in case of digital forensics. Then next we are going upon, we have down here USB devices which were attached to the system. So this is some fingerprint reader which was attached. Drive was attached here, a card reader was attached, and a data traveler pen drive was attached, I guess. Yeah, data traveler pen drive is there. A card reader is there. The details of the device is here, and the date and time when they were attached. Okay. Now going upon to web bookmarks, what bookmarks he has created. He has created some bookmarks. Let me extend it up. See, these are the bookmarks he has created there. usc.gov.url and how to hide money from government. He must be doing some, financial fraud and card printers. And then he has bookmarked Bing also for some purpose. See the date and time it was created, the browser it was being accessed on, and the domain what he has accessed, and the data source. It is showing it all. Now, all this data, you can also save it as a CSV file if you want to export it out. Normally, you can export it from here. Okay, and if I want to see it in thumbnail view, it will be from there. Now, web cookies. And this is the web history. If I go here, these all URLs he has browsed from his system during the complete time. These are available here. Web search. In case of web search, he has searched these keywords here like potato chips, handguns, how to steal identities, how identity theft, jail time. See, as we come to know, he has done identity theft using this system actually. So he's also trying to search how much is the jail time, how much I'll go to jail if I do the identity theft. Next is ID theft, fast gateway cars, how to disappear without a trace. Now see, I can see the selected item in the timeline feature also. Okay, now let me see the timeline when he tried to access it. So this is a timeline editor feature. See, here I am able to see the timeline of this event when it occurred. Let me change the timeline here. See, if I select the timeline here, from starting to this time to ending to this time, it will show me the files of this time. Okay, if I increase the timeline, it is retrieving the files, data, anything created into the system, anything created, modified, or anything during the time zone I'm selecting. So if I want to select the time, a specific time when the some kind of file or folder was created, deleted, it can be done through the timeline feature. See, these images were created during November 24, 2010 to June 11, 2015. And there's a lot of data available here. If I shrink up the timeline to here, let's see what data we have. These files were created that time. Okay, one document was last saved during this time, and the document name and details are coming up here. Then when we are applying some filters here, so if we are limiting the file types to media, documents, executables, I limit it only to media. See what we get here after applying the filter. See, only the media files I am able to see here. Okay, if I add an event here, a manual event from this area to this time, like I say event theft. So let me see if I get an event for that. There is no event occurring for that time. Okay, and if I want to snapshot this report, I can save it as test. Okay, it has the snapshot has been saved. And if I open the report here, what kind of report I'll be able to see? See, autopsy forensic report test. The test case name is this. Case number I did not put anything. Okay, number of images were 2. The time zone is this, and the snapshot which I have saved is this of the files. I took the snapshot of the screen and it has been created as a report. Now, if I go for GMT or UTC and the local time zone, the time zone of the files will change to GMT. And if I go for the local time zone, it will be local time zone. Now, I can also see it into the count of files in January, for example, in February, for example, in March, in April, May, June, July, how many files and occurrences were there. I can see it into a graph also for easy analysis. So see, from 2000, 2001, 2, 3, 4, 5, 6, how many files were there? So if I want to show someone that, yeah, data was being created into this till 2015 and then in 2023 only. So this can be shown in form of a graph. Now the next option comes here for me. In case of a filtered form, okay. Write it up. Now moving to the next features. Now here comes the communication features. Let me click on the communication one. Let me open the communication editor. In communication editor, see, we are getting different kind of communications we are doing from the device, including if there was some kind of chats or some kind of chat applications, it would have extracted it, but they were not available. They were only emails. So these are the emails available there. Now this is the email file here, which I can see. The messages are 11, call log 0, media chat attachment 6, and total attachment are 12. Now let's go for messages. See, Jimmy, haven't heard from you in a long time. Are you still in business? I need some more items made. Let me know. Using Hashmail, sent using Hashmail. Now, if I click it on here and right click it, okay, to view source file in the timeline, let's see if you're able to see in the timeline or not. Let's see when the file was accessed or created. See, here we are able to see the same thing into the timeline also from the right click option. Now, my module, it was open here, the communication module. Let's go back to the communication module. Now go for the another email, third email, fourth email, fifth email, sixth email. All the emails are available here. We can see it in a form of thread also. And if I go for downloading images, if any images are available there, let me see it. But no images available there. Okay, this is a Google Mail. Going through the messages. It's a mail from Gmail. Okay, there were different images into the email which came up here like this. If I say hide images, there will be no images, it will show only text. Now coming to next mail, coming to third mail. So this is a feature here, we can see different kind of mails. Now if I choose the option to visualize here, okay, so we have to do this for the right click into the account in the browse accounts table and select the visualize to begin. Okay, now this is the account available here to us. These both accounts are there. This is the device. I'll have to visualize it. Let me refresh it out. Visualize only. Let me see. This showed me here from where the mail went to which person. So this is the Wilson Jimmy 807 at gmail.com, and this is mail no reply at google.com. So the mail came to Jimmy from Google. And if I go for another email file, if I select multiple files here, and then I go for visualize, see, it is showing me a kind of a chart here, kind of a web, what different kind of features are available. So from Wilson Jimmy, Joe's that guy is connected, no reply from Google, the mail came to him. Mail and no reply from here, the mail came to Jimmy. Robert GMX. These are different emails which were exchanged between them. So you can see it in a form of web. Now, if I snapshot it, it will also be saved as a snapshot. So whenever you're doing the analysis of a digital evidence, this is a very handy feature for you. Like you can very easily detect any kind of communication going on through the format of this visualization. Now see here, I clicked on the encrypted files. Okay, so TrueCrypt is there. He has used the TrueCrypt into the system. And this is thing. Now TrueCrypt encryption will not be directly broken by this. For that, we'll be needing different kind of plugins. So I'll not go deep into the encryption part. Then moving next further, the exif metadata. Okay, this is the exif metadata available for this kind of file. This is the application file, the image. Now going for the file metadata, again the file metadata is there. Okay, the analysis result shows here, it's the metadata, and the analysis score is not calculated for it. Anywhere else it was occurred? No, it was occurred only in one place. Now going down, extension mismatch. Yeah, I told you, if in any file the extension mismatch has been detected, we'll be detecting it. So these are the files in which the extension mismatch was detected. Now let us check here. The file type, source type is the file type. Okay, and the file path is this. The extension is SMT, and it is telling that the extension was mismatched. Okay. Now let me add it to the hash set. Now, what are the hash set here? We can have a local or remote hash set here from where we can match the hashes of the file. So let me create it. Name as test hash. I'll have to select the path. My system just slowed down. Little bit of patience. I save it here. Okay. So now this file has been added to the hash set. Now later, if I use this hash set for matching the file's integrity, it can be used there in the same manner. Now going to the next word, keyword hits. Now what were the different keywords that were hit? So 808 emails had these many keywords which were hit. These are the basically all the email addresses. So see, this email has hitted in these many files. These are these many keywords which were hitted here. These are the emails. Okay. Now single little keyword search, there were no one. Regular expressions were not there. Emails were there. 808 emails. And these are different 808 emails which were having different hits. Like for example, this is having 2 hits, this is having 5 hits. Let me move down. This is like having 3 hits. If I click on it, it will show me all the 3 places where it is having hits. If I click on this email, it will show me the data for that. This is there. Okay. Moving to next one. Okay, moving to the next one. We go here. User content suspected. Like what was the suspected content? I told you it can automatically, through its rules, detect some suspected content. So there is some CCTV camera which was detected as CCTV suspected content. This is a file which was being detected as suspected content. This and this was selected as suspected file. This hard drive. It is, I think, some CCTV device or some kind of machine, a chip. This is, see how this ATM keyboards are basically, we use the sniffing devices there. So this is basically a fake keyboard which is being put up on the original keyboard of the ATM, so that we can basically sniff out all the data what users have entered into it. So we have keyloggers. One are the hardware-based keyloggers, one are software-based. So this is the hardware-based keylogger. And this is some kind of video. Okay, now let's go to the operating system accounts. So these are the system profiles inside them. This is the administrator, it's the guest account. Billy Bob has the account. Home group user Jimmy Wilson has the account. Okay, local network service accounts are there. Now tags, we have no tags there, and the reports available is this. Now, if you want to go for the discovery of artifacts, so we are going images. So we can select here. Now let me show you this extension. Here we can select any image which is above 200 MB, 50 to 200 MB, 1 to 50 MB, the size from file size. Okay, or we can select from the data source, whatever data source we have, or we can select from the occurrences. It is unique, rare, common, very common, or known. Okay, or which is possibly user created. We have selected this. Okay, and if we add any hashtag to it, we can check from there also. Now let me go for some video. Let me find some video here. 100 MB to 1 GB video we have. No videos were found actually. Going for new search. Any video which was of this size. No videos are there inside it. Go for images. It is searching. See, these many images were found there. Let me show you this. There is something related in a language I cannot read. Spam Nation, a book by Brand Kurtz. This is again an image. So all the images are available here, which were between these sizes. Okay, and if I make page size 200, see these many are available. These many images were available here. So this is the feature where we can search it out. Now from 16 to 100 KB, these many images are here. And from 0 to 16 KB, very small images are these many. This is the discovery feature. Now going to the next part, documents and domains. Now let's see what domains are available there. See, these many domains were browsed by him. Bing.com, Google.com, Facebook.com. And the page views were Zebra.com, Doubleflip.net, Microsoft.com, Live.net. So if you want to see the web history analysis of some kind of system, so there are different open source tools available for them also. But Autopsy, I am actually showing the demo of Autopsy here because Autopsy is a tool which is integrating everything into one. So it's a very handy tool for anyone. Now, going for geolocation, if we have anything in the geolocation here, there are no data sources found with geolocation. If there were any geolocation artifacts, it would have shown here in the geolocation tab. Then the final one comes, generating the report. Now I click on the generate report feature. Now what kind of report I want to generate? HTML, Excel, text file, data source summary report, the hashes which I tagged them in the tags, extract unique words. Okay, Google Earth KML file for the geolocations. It can be exported in the form of KML files and used later. A portable case file. So I'll go for HTML report and then I'll go for other options also. Firstly, so if I want to put any header or footer of the file, like for example, I put it application report for Gmail case, not for legal purposes. If I want to put it, not for legal purposes, only we do as personal opinion. Okay, I go for next. Now this data sources have to be included. We can select it from here. Multiple data sources. Now all result or the tag result. I'll go for all results and I finish it out. Now the report is being generated. I can open the report from here. See, the report has been opened here. The case summary is showing me the case summary. Okay, and see the header and footer which I said, investigation report for CB case, and see here came the footer, not for legal purposes, only to be used as personal opinion if I want to give it to someone. Now what happens? See here in the image information we are having the time zone, path. Okay, we are having the software information, whatever modules we have used in Autopsy, the information of the modules, which version was there. Okay, so it can be tomorrow challenge in the court, or if some examiner asks for it, which version of the tool you are using, it is present here. Now the ingest history, what is the data source? Okay, what are the modules which are enabled? What is the second data source and what are the modules are enabled? Now different email accounts found into it. Okay, different data sources I have used. This was the OS type of Windows of Gmail Resolution system. Email messages. If I see it here, the messages are complete messages are written here. EXIF metadata. Encryption suspected files. Okay, installed programs. See, this is the list of installed programs. Whatever you installed in the system, we have got all the list of the programs. These are some system files also present there and the temporary files also. Keyword hits. What are the different keyword hits for different emails or different words? Metadata. Okay, operating system information, recent documents, recycle bin, run programs, what programs, what they were run, then shellbacks, tagged files. I did not tag any file. I did not tag any image. I did not tag any result. USB attached devices. Okay, user content suspected, which was suspected automatically by it. Then next we go for web bookmarks, web categories, web cookies, web history, and web search. So this was basically the report we can see into Autopsy tool. Okay, in case of HTML report. Now if we go for any other kind of report, like I go for an Excel report. Okay, then next, again, finish. Let's create an Excel report. We are not be able to cover all the features of Autopsy tool here, but yeah, I have tried to get you through most of the things. And basically, what my purpose is, you can explore this tool yourself, and there are many other open source tools available, which you can combine with Autopsy, and it can become a complete, open source tool for you. Yeah, it will not be with the mobile forensics analysis. So mobile forensics will have to go to different tools. But yeah, in case of disk forensics, it's an excellent tool. And this is the operating systems installed there, the web bookmarks list in form of Excel file, the web cookies, the email messages, Okay, suspected suspected encryption files, web search data, email accounts, and data source. These all are given as a Excel file here in this case. And if you want to go for the other reports format, you can go for other report formats also from here, like a text file also, a comma limited text file, or a tab between, like a tab means the space will be given between the the different rows and columns, and the comma delimited also. And data source summary report, save tagged hashes, extract unique words. Okay, so unique words report, let me find it out. It will generate a text file. Now, the most important thing comes with this is it is showing us deleted files, but is it able to extract them, or are we able to count the files through Autopsy? The option will be yes, we can carve the deleted files from Autopsy. Now let me come here. See, it is showing us these deleted files. For example, there is an image. I want to extract the file, and let me put it to some folder where I can show you it in the demo analysis. And I created test 2. The image will be exported. Now we need to browse to that place, data D drive, demo analysis. This is the corrupted file. So yeah, we are able to extract it, but if some file has been corrupted, that won't be actually repaired by Autopsy. Let me go for any other file which will be open, some PDF file or something. Yeah, that's the text file. Extracting the file. But it got extracted. Demo analysis. Save. Let's go to the same folder. Let's see, this file is also corrupted. It's a blank file which we got here. So yeah, there are deleted files which can be extracted from Autopsy. Let me extract multiple files. We can extract multiple files also. And let me save it to the same folder. In the image I have taken, the files are actually corrupted. So let's see if any image opens. All the files are saved there. Let's see if any image opens up here. So the images are corrupted. I'm really sorry, I'm not able to show the corrupted file recovery through it. But yeah, the files can be deleted files can be extracted through Autopsy. And if you want to extract a normal file through it, which is not being deleted, then again the same procedure is there. We can extract a file and save it here. Image news fetcher. File image news fetcher. This file format is not supported. Let me open it through Autopsy only. Now this file is not supposed to be viewed. Yeah, the image you can get it for it. Yeah, these all images are viewable, which we can view through it. So the extraction can be in the similar manner. Going to this, going to my data, going to demo analysis, just to then saving it here. Yeah, the image came up here. You're able to see it here. So these were basically the features of Autopsy, which I covered it here. Okay, and there are multiple open source tools available here, but the Autopsy is the most accessible and the easiest one. So I opened it here, and you can explore Autopsy more through their website. Like Basis Technology has a basic training course, also free course available, and many courses are available there for Autopsy there. Okay, there are some zip files also there. The zip files can also be extracted. This is the metadata of the files. So this was the image we analyzed here. Now after this, we'll move on to some challenges which I told you I would like to discuss in the last. Yeah. Now, what are the hindrances to digital investigations, and why, in my opinion, open source tools are not actually enough alone for investigation of digital evidences? See, firstly is the data encryption. There are software versus hard encryption, hardware-based encryption. We have TPM. We have Apple-based encryption. So in that case, open source tools are not actually enough for investigation of digital evidences, because we can see open source tools are offering us capabilities, but there's not every capability supported into this. Like for example, Magnet is a professional tool which is using magnet.ai for using the categorization and automatic detection of some kind of nudity based text or some kind of explicit image, which is not available right now here in open source tool. Okay. Similarly, FTK has got the best carving capabilities compared to FTK Imager, but it is a paid tool, but it is offering us a better, carving possibility. If you are going for Passware, if you are going for Alcomasoft, okay. So these tools are their password breaking tools, which are professional tools, which are paid tools, but they are offering us better expectations than a free available tool or open source tool for this. Next is data hiding in HPA, DCO, Slack space, TPM, which is not easily being detected by open source tool. For that, you will need some time the paid tools. But yeah, there are also open source scripts and GitHub archives available where you have the functionalities related to it. Next, Nowadays, we have the covered communication channels like Tor, VPN, private messaging, like Telegram is there, Signal is there. So extracting the data from those, applications, if they were used in some system, or especially extracting the data from mobile phones for these applications, it is not very easily possible with open source. And commercial tools also, I won't say that any commercial tool can't guarantee the extraction of this data because it is a challenge for us in digital forensics. Now, steganography. For detecting steganography, many open source tools are available, and many file forensics and photo forensics tools are there. But still, advanced steganography needs to be detected from some kind of professional tools only. Anti-forensics is there, cloaking techniques are there, obfuscation of data is there, these all techniques. Then comes to the jurisdiction, which is the biggest challenge. The legal perspective of privacy and evidence collection and analysis through open source tools is a very big challenge because most of the judiciary, they are relying on paid tools, they are relying on commercial tools. Most of the police departments, most of the law enforcement, they are relying on the paid tools because of their you can say they have a trust that they can recover the data, and you have a questionability, you have the uh, answer from the OEM if they are not able to do it. You have the support from the OEM, you have the version updates, you have the latest research and R&D available for those tools compared to open source tools. But yeah, there are also some law enforcement departments which are completely relying on open source tools, and they are able to do wonders through that also. So it just depends upon the kind of investigation you are needed. For example, if you are going for some blockchain based investigation, or if you are going for some cryptocurrency based investigation, a combination of both the tools will be required, like some open source intelligence through open source tools. Some paid tools may be required for that, for decrypting the things. If you are going for some ransomware attacks, the open source is also available, the paid tools are also available. So there the combination may be needed of both the technologies. Now, the policies between the law enforcement and the intermediaries, or companies governing the data, companies governing the tools, it is a very important factor which which is placed into the concern when we are using some tool, because what support is being provided by the tool owner to the law enforcement, what the law enforcement expectations are there from the tool, like what is the use case they are using for it. This is the most important purpose for choosing a tool. A tool may be good for one kind of user, but it cannot be good for another kind of user, because it totally depends upon the tool capability and the use case, the type of data you are using it. And last thing, the social media, cloud spaces, IoT, these things are not readily available to be analyzed by open source tools because not much open source technology is available for analysis of these tools. I would say that commercial tools are there. Some commercial tools are offering the capability for this, but every capability is not being offered by commercial tool also. So the question comes, are we able to really extract it all with open source tools? It can be done only with the regular R&D into open source tools and the joint research from law enforcement perspective, also from the commercial organizations perspective also, and students also doing R&D into the open source tool. Like for example, Autopsy is a very good tool, and lots of plugins can be put into it for using it for different capabilities. But that will require R&D, and every type of use case, every type of evidence needs to be analyzed into a specific manner because no two evidences are same. For example, there is one image file which from which Autopsy may be able to extract the data. Another image file, Autopsy may not be able to extract the data because of some file system errors, because of some data corruption. So in that case, some paid tool may also be required with Autopsy to be used as an alternative or to be used as a support. So there the main tool will be the open source tool, and the supportive tool will be some paid tool required for extracting a specific kind of data. Or you are using some paid tool and some information is there which can be extracted only through any open source tools. For in that case, we'll be going for the open source tool. Like for network forensics, we have a lot of open source tools. For image forensics, we have a lot of open source tools. For data forensics, we have a lot of open source tools and distros and OS available. While we are going in case of mobile forensics, it's a very big limitation because in mobile forensics, not many open source tools are available, and we are exactly and totally, I would say totally, we are relying on paid tools only. So yeah, investigation with open source tools is preferred for all the people who are new into digital forensics. and who are doing small level of investigations. While if you are doing some professional investigation and you want to get quick results, you should definitely go for commercial tools. So basically here I would like to end up with my lecture, and I would like the questions, is there any are to be asked by the audience.
Thank you very much, basically, for your time and your experience. You have shared a lot and you have showed a lot practical experience also while demonstrating things. So there was just a question from the audience. We'll just take it. So they are asking if NCase or FTK, which one is better and which do you suggest?
Hello, Nikhil.
Yeah, am I audible?
Nikhil, you are not audible.
Just a minute. Am I audible now? Hello? Hello? Am I audible? Hello? Hello? Am I audible? Hello, Yugalji? Hello?
Hello, Nikhil, you are not audible.
Am I audible now? The audience says yes, I am audible, but I think, can you check? I have posted a feedback form also, guys. Can you just fill the feedback form into the chat of the YouTube? Hmm. Are you able to hear me, Yugal? Hello? Hello? I think Yugalji is not able to hear us. Uh, that's okay. So I really take the opportunity to thank
No,
him.
Nikhil, you are not audible.
I take the opportunity to thank him and for his wonderful time and the experience which he shared with us. Really, thank you. We are thankful from the Cybersecurity India team for your wonderful time, patience, and all your experience. And I hope the audience also enjoyed a lot. And I just request to fill the feedback form which I posted it into the YouTube chat window. Okay. So thank you very much, everyone, for joining today and attending this session. Let's meet at the next session. Thank you. Thank you.